Hi everybody, I'm Annie. I'm the tech lead of Chrome's speed metrics team. We design the performance metrics in Chrome, and we work to standardize them so they can be available in other browsers and tools too. Today, I'm really excited to talk to you about a new metric we've been working on, Cumulative Layout Shift. It's our first metric that focuses on user experience beyond performance. We're going to do a deep dive on how and why we developed the metric, and how you can measure and improve it. I'm also happy to be joined by Steve Kobes, the engineer who led design and development on Cumulative Layout Shift. He'll be able to give you all the details about the design process and the choices we made along the way. Let's start with the problem. It's a really frustrating part of the web today. You're trying to read a page and suddenly the content moves around and you can't find your place. Or worse, you're trying to click on something and then the content moves and now you've clicked on the wrong thing. And it isn't just a problem during page load. It can happen well after the site is loaded. I know it's really most frustrating to me when I'm reading an article and I'm scrolled halfway through and then the content shifts around and now I have no idea where I was. But if you're developing a site, it can be really hard to know you have a problem. Maybe it looked fine originally, and an upgrade made things shift around. Maybe it only shifts on certain viewports or on slow network connections. We want to help developers address these problems by providing a metric that measures how bad the layout shift on a page is, and making it available in both lab tools and in real user monitoring. So we spent a lot of time working on it. We looked at thousands of sites, and we tried a lot of approaches. I'm going to hand it over to Steve to talk about what we came up with.
Hello, I'm Steve, and I'm going to tell you a little more about the design of the CLS formula and how the browser measures layout instability. To quantify layout instability, we looked first at how much of the visual area on the screen was affected by it. We call this the impact region. So here's an example of a page where the content jumps because an ad was inserted. We first identify all the DOM elements that shifted from one animation frame to the next. So let's see the jump again. And in this case, we identify the big white block of text as a shifted element. Now, of course, the reason this element shifted was that an ad was inserted, but the ad itself is not a shifted element because it didn't exist in the previous frame. We don't want to penalize inserting new elements because that's a very common thing that happens during progressive rendering as chunks of the page are loaded from the network. So we're really focused on elements that already existed but are now in a different visual location. Once we have that set of shifted elements, we take the union of the before and after state of the visual area of each shifted element. So here's what it looked like before the shift, and here's the previous visual area, and the new visual area. So we combine those for all the shifted elements, and that gives us the impact region. And you can see in this case, the ad is actually inside the impact region, which might seem appropriate, but the ad is not directly contributing to the impact region. The reason it starts that far up is that we're including the previous visual area of the white box with the text. In this case, the impact region is a rectangle, but it doesn't have to be. If there are many shifted elements in the same animation frame, or if an element shifts both horizontally and vertically, then the impact region can be a more complicated shape or even a union of disjoint shapes. But in any case, we look at the size of the impact region as compared to the viewport. And this gives us some normalization across different device sizes, window sizes, and resolutions. We really want to look not at the absolute numerical area, but at a ratio. And the ratio of the impact region to the viewport gives us a fraction, which we call the impact fraction. So our first prototype of CLS looked only at the impact region. But we noticed this didn't do a good job of capturing how far things moved. If something moves a lot, it's more distracting. But if it only moves by a few pixels, it's not as bad, even if the area of the thing that moved is large. So we decided to ask, what's the farthest distance that any shifted element moved by? In this case, the shifted element moved from here to here. So that's our maximum move distance for this frame. We compare that to the viewport and get another fraction, the distance fraction. I should also note in this example, we only have vertical movement on a tall device, but move distance is axis agnostic. So the top of the fraction is really maximum movement distance in either the horizontal or the vertical direction. And the bottom of the fraction is really the viewport width or height, whichever is larger. So now we have two fractions that we want to incorporate into an overall score, the impact fraction and the distance fraction. When we multiply them together, we get the layout shift score for a single animation frame or a single moment in time in the browsing session. And if we add them up from the start of the page load till the user leaves the page, then we get a cumulative layout shift score or a CLS score. Another problem we ran into was that websites are interactive. And we didn't want to give a bad score just because the rendering changed in response to user input, like clicking a button to expand something. So a naive solution here might have been for CLS to ignore layout shifts that happen inside event handlers. But layout shifts in response to input don't necessarily happen synchronously inside the event handler. The shift might happen after a network request or inside a task in a custom scheduler. And in general, it's really hard for the browser to trace a layout shift back to an input through these kinds of asynchronous steps to really understand that the shift is because of the input. So our solution is to not even try to do that, but instead to basically give you a window of time after a click or a tap or a key press when you're allowed to change layout without bumping the CLS score. And we call that the input exclusion window because we're excluding the layout shifts that happened within that window of time. Another challenge we faced was with animations. And we saw that a lot of sites with high CLS scores had animations like auto-advancing image carousels. CSS lets you animate any property you like, but if you animate a layout-related property, like the position offsets left, top, right, and bottom, then we're rerunning the browser's layout engine on every animation frame, and every frame produces a layout shift. Now, it might be a small layout shift, that is the impact region and the maximum movement distance are both pretty small for each frame, but the cumulative score will grow unbounded. So your total CLS will be large and proportional to how long the user spends on the page, which is not very good. The solution that we adopted was to ignore changes to the transform property. So as long as your carousel is implemented with transform animations, it won't blow up your CLS score. And in some ways, you could say this is a bit of a hack, but we think this is really in keeping with the principles of punishing layout instability because transform doesn't influence the surrounding layout. So if you shift an element by transforming it, none of the elements below it will move around. But if you shift it with a position offset, then they can. Transform also means browsers can easily parallelize the rendering by running the animation on a separate thread from the thread that runs the JavaScript. This means the page will be more efficient and responsive, even if it's script heavy. So that's an overview of the CLS formula and some of the trade-offs that went into it. We know CLS doesn't correlate perfectly to the user's perceptual experience of layout instability, but it tries to capture an approximation of it in a way that's easy for the developer to reason about. It doesn't give the full story of the user's experience, but we think that that full story can be approached by CLS in conjunction with other metrics like largest contentful paint and first input delay. Finally, I'll note that the definition of CLS will probably change over time as we incorporate feedback and look at how it's used on the web and how we can make it a more useful signal. All right, I'll turn it back to Annie now to tell you more about how to improve CLS on your sites. Thanks, everyone.
Thanks, Steve. So now that we know what Cumulative Layout Shift is, let's talk about how to measure it and improve it. First, how do you see your site's Cumulative Layout Shift? We've made it available via a few different methods in the lab and in real user monitoring. Let's start with the lab. First, Cumulative Layout Shift is available in Lighthouse 6, which is currently in beta. You can see the score right in the metric summary at the top. Here's a screenshot. We're also going to add additional debugging info and audits to Lighthouse over time. Cumulative Layout Shift is also available in Web Page Test. It's going to show up in the timing section for each run really soon. But maybe you're stuck at home and you don't have anything to do and you really want to see your score in Web Page Test right now. It's already available in the raw JSON as Chrome user timing.cumulative layout shift. Here's a screenshot of a web page test run. You can get to it by clicking View JSON Result from the main Summary tab. If you run automated tests using Web Page Test, you can parse this JSON for the Cumulative Layout Shift as well. But what about real user monitoring? The easiest way to get started is to use the Chrome User Experience Report. Cumulative Layout Shift is in the table as layoutinstability.cumulative layout shift. Here's an example query that outputs a histogram of scores for a site. But what if you want a more fine-grained detail for your site? Cumulative Layout Shift is exposed via a JavaScript API in Chromium browsers. Let's walk through some example code. First, we want to create a variable to store the sum of the layout shifts. Next, we'll create a performance observer. The observer is notified of layout shifts. Notice the buffered argument to the observe method at the bottom there. We can start observing after the page is loaded and get buffered entries that have already occurred. No need to block loading with the script to start observing. We'll track entries with type layout shift. And since some shifting is expected after a user input, we'll ignore entries that had recent input. The rest we'll add to our cumulative score. Finally, when the page is hidden, we'll force any pending records to be dispatched and report them. This code mirrors the way we report Cumulative Layout Shift in the Chrome User Experience Report. But the API is pretty flexible. You can imagine tweaking it. Maybe you want to measure layout shift before the page loads and after the page loads separately. You could have two different scores or reset the variable. Same thing if you had a single page app. You could track the score for each route separately. In fact, the API doesn't even require that the layout shift score is cumulative. We're just adding it here, but you can imagine doing something different. Like, for example, calculating a rate. Maybe you want to know the layout shifts per minute. So that's a summary of how to measure cumulative layout shift in the lab and in real user monitoring. But now that we know how to measure it, what's a good score? Ideally, pages wouldn't have any layout shift at all, but that might not be reachable for all sites. So our team thought a lot about what a good score for layout shift might be. We dug through sets of pages that consistently scored in different buckets, and we came to agreement that if you sum up all the impact fractions multiplied by all the distance fractions, 0.1 is a pretty good score. We recommend trying to stay below it. So what if you measure your layout shift and it's really high? What can you do? We're working on adding additional audits to Lighthouse and debugging information to DevTools. But right now, you can see layout shifts in DevTools. It's a little bit buried. You need to use the More Tools menu and open up the rendering panel. Once you're in the rendering panel, select the Layout Shift Regions checkbox. Then, as the layout shifts, the shifted content will be highlighted in blue. It's updated as you interact with the page, so you can see layout shifts that happen after load. We found that as we've dug into a lot of layout shifts over the past year, being able to see which content shifted the most was the most helpful part of debugging. So we think this is a really useful feature in DevTools, and we're also working on adding a list of shifted elements to our JavaScript API. So now let's get to common problems. We've looked at a lot of layout shifty pages over the past year, and we've even done analysis to understand what the biggest sources of layout shift were. We'd like to share some of our findings and help out with addressing some really common problems. First, one of the very most common causes of layout shift is unsized images. I threw together this quick page as an example. You can see that the images are unsized, so the text pops around a lot as it loads. I changed my example to just have width and height attributes for the images, and now the layout shift is gone. If it's possible, always add sizing attributes to your image and video elements. If not, look into techniques to reserve the space with CSS, like I've linked in the slides. Another really common cause of layout shift is fonts. Especially on slow connections, text can display before the font is fully loaded, and then everything shifts around when the font loads and the text is updated. To address this, consider font display optional. This CSS shows the fallback font if the font isn't loaded, without doing the swap when the font does load. But it still makes the request so that the fonts catch for next time. If font display optional isn't an option for you, then try to match the font metrics of the fallback font and the web font as closely as possible. There are font style matching tools to help. I link one in the slides. Another cause of layout shift is content that's injected after the main content is loaded. Often it's these little promo bars at the top of the page that the user can close. If you can't reserve space for this type of bar, consider making it position fixed so that it just overlays the content a little bit. But a worse cause of layout shift is larger injected content. The best thing to do in this case is reserve space for the content ahead of time, so that things don't shift around as it comes in. Another really common cause of layout shift is just flash of unstyled content. This example is a really common case we see. This site's using a normal Bootstrap menu, but it loads the CSS really late, so you see the full HTML of the menu laid out before it's properly styled and hidden. I recommend that when you're looking at the order to load resources in, always consider really carefully what styles are needed to display the initial content correctly. The last really common anti-pattern we see is animations that trigger layout changes. These animations run on the main thread, and when devices are slow, it can cause a lot of jank. It's much better to prefer transform animations to animations of properties that trigger layout changes. Thanks so much for listening. I really hope it's been helpful to learn about how to develop the metric for layout shift and how you can measure and improve your own site. Our team continues to work on new metrics and improvements to existing metrics, as well as web performance APIs. As we look back on the development of Cumulative Layout Shift, one thing we'd really like to improve upon is working more with the community. We're taking a break from Twitter right now, but we'd still really love to hear from you. If you're interested in our work, or if you want to contribute or give feedback on performance metrics and APIs, please reach out at speedmetricsdev@chromium.org. Thanks so much.